Hi everyone, welcome to today's webinar surrounding DevSecOps today. We'll just wait a few more minutes for more people to join on to the webinar, so welcome all. Welcome to anyone who's joining now to our DevSecOps webinar today, Not So Secure. We'll just wait another minute or so to see if any more attendees arrive. This is our DevSecOps webinar. Welcome to people who've just joined us here. We'll just wait a few more minutes and then get started with the webinar. Okay, well let's start this webinar now. Welcome everyone who's just joined to our DevSecOps webinar today. I'll now pass you over to Alan, who will just give a brief introduction. Over to you.
Okay, thanks Leslie. Hi, thanks everyone for joining. Really appreciate you coming on board and keeping your chin up in these unusual times. As mentioned, my name is Alan Pantning. I'm lucky enough to have a great role, a part of a global team. Who, what we deliver effectively is an ethical hacking service and training service to what we consider world class. Anyway, shortly I'll be handing over to Abhijay Singh, who is one of our security consultants. He's also a black hat trainer and an accredited pen tester. If you don't mind, just before we get going, I just want to take this opportunity to briefly tell you a little bit about us. Not So Secure is part of the Clarinet cybersecurity group. We do two things effectively. We hack and we teach. That is it. Under that banner, there's obviously a few more things like, you know, there's pen testing, there's red teaming, there's security consultancy, there's training, NDR, continuous security testing. So there's quite a variation, but it's two main things: hacking and teaching. We've been doing it now for about 20 years, so hopefully we know what we're doing by now. We're very proud to call ourselves one of the largest hacker trainers at Black Hat. Black Hat run generally in August every year, and just in the course of a week, we normally train about 500 or 600 people in various skills of hacking, whether it be on DevSecOps or right through to advanced infrastructure or whatever. So yeah, I mean that is our big event each year. But you know, Black Hat runs at very different locations, and we attend lots of other conferences. On the training side of things, we also partner with a couple of the large organisations like QA Training, Checkpoint, which is HackerPoint. So you know, we're quite up to date in the training arena. So DevSecOps, why? You know, what and how? It's a well-known fact that web application vulnerability is on the rise. So if you work in an agile company where code is forever being changed, it's a bit of a no-brainer really that, you know, you need to do more than annual pen testing to keep on top of it. The really best way to do that is obviously you know, to combat, you know, is to get your skills. Everyone working in the software development life cycle, you know, upgrade their skills so that developers are educated in responding to this rapidly growing security risk. In this webinar, we'll be looking at how developers community can, you know, update their skills to actually tackle these threats on a proactive basis. Just a quick note though is the webinar it's an introduction. It's more of a flavour into you know, the full course that we do, and a lot of the content is actually taken from the course which was originally developed about 2 to 3 years ago. As you can see on the screen there, we're also running a promotion. And effectively, if you want to know a little bit more about any of our training, you know, just have a chat with one of our consultants, and what we do, we'll enter you into a prize draw to get a free space on one of our training courses. So there's not a lot to lose. So anyway, without, you know, waiting any more time, I'll hand you over to the main man, Abhijay, if you can take over. Cheers.
Thank you so much, Alan, for the great introduction. A very good afternoon to each and everyone. And before we begin, a bit about myself. So I'm Abhijay Singh. I'm working with Not So Secure for the past couple of years. I have expertise in application security, networks, vulnerability assessments, ranging around different finance and banking institutions, which has led me into looking at options for going ahead and performing automation around these areas, and which interested me in the topic of DevOps and DevSecOps. I have gone ahead and presented the application security for developers course and the DevSecOps course in various international conferences as well. Now, a brief about what you will be going ahead and taking away from this course. So one of the key things to understand over here is that this is more of a platform agnostic course, which means we have found that the developers are able to go ahead and relate what are the different vulnerabilities that they can go ahead and identify within the applications. And once they do this, we go ahead and help them understand how they can automate that process, how they can go ahead and understand what exactly is DevOps, how they can go ahead and inject security into the CI/CD cycle, understand what exactly is the term called as security champions, understand how it is easy, how it is more viable to go ahead and find and fix bugs very early into the SDLC system, see how they can go ahead and build a secure by default infrastructure, and also learn about the key principles related to continuous security monitoring. Now, the agenda for today that we'll be going ahead and discussing. So first we will begin with an introduction to DevOps. We'll learn what exactly is DevOps. Then we will go ahead and move forward to answer the three main questions of what, why, and how to do DevSecOps. Then we look at the different ways in which we can introduce security in a DevOps pipeline to achieve DevSecOps. We look at the different tools of trade which can be implemented in the DevSecOps pipeline. We will also discuss different sample implementations as well. And finally, we will look at the different cultural aspects surrounding DevSecOps. Now, before I go ahead and start discussing the different topics, a quick disclaimer that the complete course of our DevSecOps training is based around a lot of tools. Now, one thing we would like to go ahead and clear out is that any tool that we are going ahead and discussing within our course, it is not an exhaustive list. There are different tools that are present in the over the internet, which you are free to go ahead and try it out. Any tool that we have used within our training, within our lab, the whole idea or the whole purpose was how easily it was integratable to our environment, right? So to give you an example, like how WordPress is to internet development or code development, we have gone ahead and used Jenkins, which is very similar to what is being the most used tool in DevOps. So that is how we have gone ahead and used the different tools. We do not endorse any tool, any specific vendor, and there are multiple ideas that we will be going ahead and discussing. There will be multiple case studies that we will be going ahead and discussing. However, please understand that DevSecOps is not a plug and play wherein you can just pick something off the shelf and just try to implement it as it is. If you want to go ahead and implement or start working in for DevSecOps, you might have to go ahead and first test and validate these ideas, these implementations within your organization. Start small and then see how it works out. Do not try to implement a solution as it is what we recommend. Now, without further ado, let's go ahead and start and understand what exactly is DevOps. Now, DevOps basically goes ahead and revolves around the four pillars, which are continuous integration, continuous delivery, infrastructure as code, and continuous monitoring. Now let's go ahead and dig down deeper into each of these aspects to understand these terms far better. Now, in continuous integration, we have a developer where we have multiple developers actually who are going ahead and checking in their code into a centralized repository. So basically every developer is checking in his part of the code, and it's continuously going ahead and getting integrated without any manual intervention, and that is what is called as continuous integration. In continuous delivery, we have tools such as Jenkins, probably Circle CI or Travis CI, which basically pull the source code from the software code repository, and they go ahead and perform two actions. Now, what are the two actions that they will perform? The first action is that it will go ahead and create a build file or probably an artifact file, such as a war file or maybe a jar file or a zip file, depending on the environment that is present. And the second action that it performs is it will go ahead and deploy that created artifact. Now, one very simple question that I always face in my classes is, where will Jenkins go ahead and deploy this artifact? So deploying the artifact in a static system, like probably a web server which has been set up on a virtual machine and which has been manually installed and configured, if you have such a kind of a setup within your environment, then you're truly not doing DevOps. In DevOps, your complete infrastructure, like your servers, your web servers, your databases, majority of your infrastructure, it should go ahead and get spun up using simple lines of code. So the whole idea about infrastructure as code is to go ahead and eliminate those lengthy manual configuration files which were used by administrators or operators to go ahead and provision a system. And one of the most widely used tools is in infrastructure as code is Docker, and we have heavily used Docker in our lab. So Jenkins basically goes ahead and bundles the entire application, creates a Docker image of that particular application or the server. So to further explain you, let's go ahead and have an example. So let's say we have a Java application and Jenkins will go ahead and create a war file. It will also create a Docker image of the tomcat container, which will hold that particular war file. And then the Docker image is pushed into a public or a private repository, from where it will be pulled onto a Docker host and gets executed. So this is the complete flow on how a continuous delivery would happen with infrastructure as code. So up till now, we have gone ahead and understood how continuous integration, how continuous delivery and infrastructure as code has helped in automating, has helped in faster creation of the project. Now, since DevOps is a very fast moving environment, and in such an environment, suppose there is an issue that happens within your infrastructure or probably your application, right? You cannot really have your operations guy or your administrator go ahead and do probably an SSH into your system and fire commands probably like tail-f on the log files to see the different logs. In DevOps, you need to have a real-time view of your logs, and to enable that, we need to go ahead and use something called as a very famous FELK setup. So FELK stands for Filebeats, Elasticsearch, Logstash, and Kibana. Now the combination of the FELK stack or these four technologies helps us in going ahead and aggregating the logs, visualizing the logs, and alerting or suspicious or probably a problematic issue that gets occurred within the application to the respective stakeholders. So this is a sample implementation of the DevOps lab that we have gone ahead and created for the training. So let me explain you this complete lab now. So we have the developer who is going ahead and checking in his code into a centralized repository. We have Jenkins, which will pull the which will go ahead and pull the code from the, or pull the change from the centralized repository and perform the two actions. First is creation of the artifact and pushing the artifact into an artifact repository. Second, going ahead and creating a Docker image and pushing it into the Docker registry. Now the staging and the production host will go ahead and pull the latest images from the Docker registry and deploy our application into the staging and production setup. Now in production host, we have our file beats, which has been configured to read all the logs and push it onto probably Logstash. And from Logstash, we'll go ahead and parse the logs, which will then make it into more of a readable format, and then send them to Elasticsearch. Now, Elasticsearch will be used to go ahead and store our logs. And finally, we will have a GUI based dashboard, which is Kibana, which will be used by the operator or probably the administrator to go ahead and view the real-time logs. Now, the complete operation over here, which is performed, which is from the developer going ahead and checking in his code into the production and getting everything deployed, everything happens in an automated manner. And in such an organization wherein this kind of a setup is present, the builds are getting rapidly generated and the changes are getting rapidly pushed into the production environment probably every hour. Now, this is a very simplistic and overview of how exactly DevOps happens within an organization, within an environment. Now, what are the challenges that will occur in such a type of a DevOps environment or a fast-paced environment? So, one of the key challenges that the security team will go ahead and face is, we already know that DevOps is a very fast-moving environment, right? And once these changes are rapidly moving, probably every hour, it is going ahead and getting deployed. In such an environment, it is a big challenge for the security team to actually go ahead and test and validate and ensure that each of the builds that are going ahead and getting deployed into the production or the staging environment are free from security issues or security vulnerabilities. So rapid deployment and rapid development is a big headache for the security team. Next, speaking in terms of scalability, I think everyone would agree that when it comes to manpower, the ratio that is always present when it is counted, like in terms of every 10 or 20 developers that are present within the organization, there is only one security guy who is responsible to handling those 10 or 20 developers. And here we are just talking about probably one single application. In a robust organization, there are so many applications, there are so many builds and changes that are getting continuously pushed onto the internet, right? Again, you cannot have your security team working as a gatekeeper to ensure that each and every setup is getting tested. You need something called as an automated setup. Next, in case of DevOps, the attack surface has drastically increased. Now, let me give you an example of a very recent red team assessment that we have done. Now, in that red team exercise, we were able to go ahead and identify a Jenkins instance, and gaining access to this Jenkins instance, we were able to practically access and exploit more than 500 applications that were configured through Jenkins. So this is one of the major changes that has happened, and this is where the security team also needs to evolve, needs to understand the attack surface of the organization. Now, one of the most important things, or one of the most important aspects when it comes to security in DevOps is the lack of skill set within the developers. Now, imagine in a DevOps type of an environment, the devs can actually no longer go ahead and say that, hey, I don't know how to go ahead and push the applications into the production. And the operations guys cannot say, hey, I don't know how to read code. The skill set which is required for having a robust environment for in a DevOps kind of a culture is very high. And when it comes to security, the dev and the op guys now also need to go ahead and understand security, understand what are the different vulnerabilities that are present in their system and how they need to probably remediate or go ahead and have appropriate controls against them. Now, one of the key aspects is that security has been treated as an afterthought. Now, generally, we will see this as a practice in most of the organizations where the security team is approached probably after the application has been deployed into the production. And then the security team has been asked to go ahead and uh, perform the penetration testing or the source code review or the dependency check or the automated scanning for that application. Now, the problem with such type of an approach is that if there is even one single SQL injection that gets identified by the pen tester in the production environment, the cost of going ahead and fixing that bug is way higher than going ahead and fixing that in production is way higher than going ahead and fixing it in the staging environment. And that is where it is always recommended to have more of a shift left approach. Now, shift left approach helps you to go ahead and move the security testing into the initial phases of the development. Now, for example, even the most simplest of the static analysis tools that you have gone ahead and configured in your CI/CD cycle, they will go ahead and help you discover trivial SQL injection vulnerabilities and cross-site scripting vulnerabilities and other low-hanging fruits in the delivery phase itself. So now you are going ahead and fixing the issues even before the application has moved into the staging setup. Now, what if we go ahead and implement the complete suite of security testing, that is going ahead and performing the automated source code review, the compliance review, the dependency checking, the penetration testing. All of this gets performed before the application has been moved into the production. And that is what we call the shift left approach. And once you go ahead and have the shift left approach implemented within your environment, what do we achieve? We achieve something called as DevSecOps. So what exactly is DevSecOps? DevSecOps is basically integration of different tools like the static analysis security testing tool, the dynamic analysis security testing tool, the container scanning, the vulnerability assessment. You go ahead and integrate all of these tools, all of these security tools within your pipeline. And that can be achieved using security as code. You need to have a security as code culture by having an automated system, an automated process in place to perform security. And finally, DevSecOps is only successful when you go ahead and promote cross-skilling. Now, this can be done by going ahead and educating and providing different trainings to your security team, to your developers and your operations people. And once you go ahead and do all of this, you achieve DevSecOps. Now, why do we require DevSecOps? We have already seen how the rapid pace of deployments and developments are a major headache for the security team. Having DevSecOps in place by having a shift left approach, having automated tools will help in going ahead and preventing security team working as a gatekeeper. You'll have automated tools going ahead and scanning them and giving out the results. You'll have a much better scale, smoother scaling of different processes because now you have automation in place. And one of the key aspects of having all of these automation and cultural changes is that it will go ahead and help in creating something called as a secure by default environment. Now, secure by default environment will not go ahead and get created probably 1 month or 2 months after you start having the DevSecOps pipeline. You'll achieve secure by default probably after an year or a half, after you have multiple cycles that you have run through DevSecOps. And the reason for that is because one of the key indicators or the key aspects of having a secure by default environment is to go ahead and have feedback. The more feedback that you will provide to your developers, to your administrators, the more faster you will be able to achieve the secure by default environment. So how are we doing DevSecOps? So the very first thing that we are going ahead and doing is in DevSecOps is at the developer's workstation. We install what is called as pre-commit hooks. Now, you guys would have gone ahead and heard about a lot of breaches that are identified wherein they have leaked sensitive information such as the tokens, the AWS keys or passwords, which are leaked into public repositories. Now, the question that arises is how can we go ahead and avoid this? So we can use the pre-commit hooks in this case, which basically goes ahead and performs more of a regex based check. And whenever the developer is going ahead and probably checking in his code or committing his code or pushing his code into the centralized repository, once you have integrated the pre-commit hook, the regex will get activated and they will check if any sensitive information is getting uploaded. If something is identified, it will stop that commit and it will go ahead and notify and provide a report specifying that an error has occurred and a sensitive information has been identified. And one such tool which will help you go ahead and do that, which will help you in preventing accidental disclosure of sensitive information, is Talisman. Next, the next thing that we are going to look at is secrets management. Now in DevOps environment, you will never see the entire pipeline is held for the admin to just go ahead and put the credentials of your database. And if that is actually not how you're going ahead and doing DevOps, and that is not actually how DevOps works. In DevOps, everything has to be in an automated fashion. It has to go ahead and have automated solutions in place. So the question over here is, where are we going ahead and storing our credentials in a DevOps environment? And the credentials over here are either stored in a configuration file or stored as an environment variable in a DevOps kind of a culture. And these credentials are actually stored in clear text, which is like a big headache for the security team, because if there is any compromise that happens, even of your Docker system, your environment variables can get easily exposed. So the solution for this is to have your environment variables handled by a secret management solution. Now, what does exactly this secret management solution do? It will actually go ahead and use or go ahead and take your credentials and convert them into a token, which can then be given to the developer to put in their code. So when Jenkins builds your code and deploys it into the staging or the production, the application running will go ahead and fetch that credential from the vault. And one such tool that will help you do that is HashiCorp Vault. Now, it is actually a Go-based binary which can be easily set up. Now, one good question that we generally get in our trainings is, what if someone gets access to the token, which in turn can actually lead to the credential disclosure? So the basic premises of how secret management tool works is, once you have gone ahead and deployed it, the vault should not be accessible by your developers, and the vault server should only be accessible to your administrator. This way, you're actually going ahead and having a controlled access segregation in place, thereby preventing any disclosure of your sensitive information. Next, we move on to software composition analysis. Now the developers have checked in their code, and till here we have some level of assurance that our code is not leaking any sensitive information. But what if our source code contains a vulnerable library? So let's take an example. Like, for example, your application is using a struts web framework of Java, and you have now coded a very good application which does not have any cross-site scripting or SQL injection vulnerability. But what if there is a vulnerability in the struts true framework that you're using, and this is the same thing that might go ahead and get exploited? Now, this is the same attack that happened with Equifax, wherein they were using the struts true framework, which had a remote code execution vulnerability. So it is extremely important that before you go ahead and create a build or an artifact and you go ahead and deploy it, you need to go ahead and run a software composition analysis tool. Now, what will this tool do? This tool will actually go ahead and check if we are using any vulnerable component or a vulnerable dependency. And these tools are executed by Jenkins itself. So Jenkins will execute these tools and identify if there are any vulnerabilities which are high. It will go ahead and fail that build if it identifies any high or a medium bug. And the tool that we are going ahead and discussing over here is dependency check. So dependency check is one such tool which is actually based on Java, which can help you identify the vulnerable dependencies. And it actually works on other languages as well. I think it supports Python as well. And there are other alternatives that we'll be going ahead and discussing in our training, which you can use as a software composition analysis tool as well. Next, we move on to static analysis security testing. So we have checked in the vulnerable dependencies up till now, but what if our source code, and what about our source code? If there is any issue with our source code, how are we checking that? And one scenario is, what if we have a junior developer who is actually following a bad practice and has put a code which leads to an SQL injection vulnerability? What do you do in these cases? So after going ahead and checking your dependencies, we can actually run something called as a static analysis security testing tool. The tool can be executed again by Jenkins, and the most basic open source tools are very much capable to identify the low hanging fruits such as cross-site scripting and SQL injection, etc. So we have findsec bugs is one such tool that is for Java that can be used to perform the static analysis security testing. It is recommended to integrate the security static analysis security testing tool at an earlier stage in your pipeline, even before your application has reached the staging setup. Next, we have the dynamic analysis security testing. So now once your application has moved on from the staging setup, right? Now we go ahead and perform dynamic analysis using tools like OWASP ZAP. Now ZAP is an open source tool which has a very rich API interface, which you can go ahead and provide a URL, the cookies and the credentials, using which ZAP can actually go ahead and automate the scanning. And one of the great aspects of ZAP is the API of the ZAP can be directly executed through Jenkins. So what we go ahead and see in this figure is, as soon as the application has uh, goes live into the staging environment or the staging setup, we go ahead and start the execution of our dynamic analysis tool. Now the question arises is, why is dynamic analysis security testing tool required when we have already performed the static analysis to identify issues like SQL injection and cross-site scripting? So dynamic analysis security testing is actually a runtime vulnerability scanner, which will go ahead and identify issues when the application is in a running phase. Also, a combination of your dynamic analysis security testing tool and your static analysis security testing tool can help you in actually weeding out a lot of false positives. And the reason for that is because static analysis security testing tools are known to be going ahead and reporting a lot of false positives. Now, we move on to the next phase, which is vulnerability assessment. Now, the thing that we need to go ahead to do in vulnerability assessment is to check whether the application in the running phase, which is either on an HTTP or an HTTPS, if the application is having any vulnerable service that can be used by an attacker to do a compromise. And this is where we have tools like OpenWAS or probably Qualys, which will go ahead and assist us in performing the vulnerability assessment. In our lab, we have used OpenWAS, and OpenWAS has an excellent CLI interface using which you can provide a domain name or probably an IP address of the machine that you want to go ahead and scan, and it will go ahead and scan that particular domain or that particular system. Next, once the application is live and it is into the production, we would want to go ahead and check if we are meeting the compliance standards like HIPAA or probably PCI DSS, etc., depending on the business or the nature of business you're performing. And this is required wherein we have different configs, like the application should not be running as root privilege, or port number 80 should be closed down, etc. Now, a lot of developers actually go ahead and also create Docker images, and these Docker images are the key to actually go ahead and use the default execution, which is actually a root privilege. Now, finally, going ahead and running your application using the default settings, using the default execution, which is the root privilege, you're actually violating the compliance or the best practice which might be set by your organization. And this is where our tool inspec comes into the picture, wherein using inspec, you can go ahead and create a very simple Ruby file which will go ahead and codify all the checks that needs to be performed, and inspec will actually hook onto your Docker container which is running, and execute that particular Ruby script and identify the compliance status of your container. The next thing that we would want to go ahead and do is container scanning. Since today, a lot of developers directly go ahead and pull the Docker images from Docker Hub or probably other open source libraries. So we don't know what the security posture of these open source libraries are and whether they have any malware embedded within them or not. And for that specific purpose, we have a container scanning tool, which is Trivy. Trivy will actually execute the scan directly on the Docker registry and spool out the different vulnerabilities against that particular Docker. Next, we have vulnerability management that lies at the heart of DevSecOps. And the reason for that is because all the different tools that we have discussed till now, like the dependency check or the ZAP or the find/seq bugs or trivy or inspec, will actually go ahead and generate a lot of vulnerability data. These data will actually be in different shapes and different formats, etc. Now, if you go ahead and give these reports to your developers, they actually might not go ahead and understand it at the first. And hence, it is extremely important that you normalize these reports, you normalize the data, and store it into a single location. And the tool that will help you in doing this is archerysec. And archerysec actually goes ahead and provides you very nice dashboards that you can use for going ahead and sharing with the developers and understanding the actual security status of your environment. And finally, we have the security incident and response. So till now we have a certain level of assurance of not having any SQL injection or excesses, or our artifacts or containers or our libraries are fine. But what if a 0-day is present within our application or our infrastructure? Or if someone actually goes ahead and identifies an instance of SQL injection within our application, we would still want to go ahead and stop that from getting exploited, and probably not just stop it, but also go ahead and identify that endpoint where it is getting exploited. And this is where we have the mod security WAF that comes into the picture. Now, mod security WAF is actually an open source WAF, which will go ahead and help us in stopping these 0-day or real-time attacks that happen against our application. So this is our sample DevSecOps lab that we have gone ahead and created, and we'll be going ahead and developing or probably going ahead and looking at in our training over a course of 2 days. This is the diagrammatic representation of our labs with all the tools that we have gone ahead and talked about. So we have Talisman, we have Vault, we have ZAP going ahead and working as our DAST, we have archerysec working as our vulnerability management system, we have OpenWAS, inspec, and this is how our complete lab looks like in a diagrammatic fashion. Now, to go ahead and give you a further understanding of our complete lab, we have gone ahead and created a video which will help you understand or have a closer look at our DevSecOps lab. So let me go ahead and run this video for you. So we discuss on how we can go ahead and learn DevSecOps using an integrated interactive browser. Now, this is one of the key features of our training, wherein each and every delegate will be provided with a personalized lab where they will be going ahead and accessing the lab, developing and deploying their own DevOps and DevSecOps pipeline. It's a 2-day hands-on training that we'll be going ahead and performing, which will be insight into the DevSecOps lab. So we do have a playbook. Now we have gone ahead and designed the playbook to go ahead and help each and every delegate understand what are the course contents, what are the different instructions that he needs to follow, and how he can go ahead and set up the lab. We have also each and every stage that is mentioned. Next, we have a very good browser-based IDE. Now, this is the IDE that we will be going ahead and using for pushing our code into the repository, building our DevSecOps pipeline. Next, we start integrating security in our DevOps pipeline. So this is our DevOps pipeline that we'll be going ahead and designing or implementing at the end of the 2-day course. Where the first stage is we go ahead and perform the static analysis. The second stage is dynamic analysis. The third stage, we go ahead and perform the container analysis. And the stage 4 is wherein we have our real-time attack detection tool. And this is a slide that goes ahead and helps you understanding how we are going ahead and designing our DevOps pipeline. And once we have gone ahead and implemented our DevOps pipeline, we'll go ahead and integrate security in the DevOps pipeline, and finally go ahead and implement our DevSecOps pipeline. The very first stage, which is using pre-commit hooks, using talisman, we'll create a secret file, we'll try to commit it, and it will go ahead and get stopped by talisman. Next, we have our software composition analysis, wherein we'll go ahead and commit, and as soon as our software composition analysis tool, which is dependency check, gets executed in the pipeline, it will spool out the different vulnerabilities that it has identified, and it will fail the build. Then we will go ahead and have a hands-on session wherein each and every delegate will go ahead and fix the issues, understand how exactly software composition analysis work, how exactly vulnerabilities are identified in the dependencies and the libraries, and they'll go ahead and fix these and build a successful pipeline after that. So here we are going ahead and identifying the vulnerable code, and we are going ahead and fixing the issues that we have identified. Now you see, once we have fixed it, the pipeline is now success. And then we look at static analysis, wherein we have semgrep that will help us in identifying the bugs. We'll integrate the SAST into the pipeline, and it will spool out the different vulnerabilities. We will fix these vulnerabilities one by one. Each and every delegate will fix these vulnerabilities and understand the impact of fixing these vulnerabilities as well. Now, each and every setup, each and every instruction on fixing these bugs will also be present in the playbook file that will be provided to the delegates. Next, we move on to the dynamic analysis security testing, wherein we will have the OWASP ZAP. Now, ZAP will go ahead and get executed in the pipeline. It will go ahead and spool out the different runtime bugs, runtime issues that will be applicable within the environment. Next, we perform container scanning using Trivy. We'll understand the Docker that we are going ahead and using. We'll go ahead and scan our production Docker image and identify the different issues that are applicable against our Docker image. Next, we have compliance scanning that we will perform using inspec. Now, one of the most important aspects of compliance as code in our training is we just don't go ahead and show people how to run inspec. We will go ahead and create a rule. We will ask each and every delegate to create a specific rule to give them a hands-on feeling, to help them understand how they can go ahead and codify the instructions. Once they do that, we'll ask them to go ahead and run them against the Tomcat server, which is their own, which will be their own personal IDE. And once they'll go ahead and run it, once they'll look at the compliance status, we'll ask them to modify that file. We'll ask them to do a hands-on exercise to log in onto that Docker, change the configuration, and see how they can go ahead and achieve compliance in DevSecOps as well. Right, so these are the different compliance aspects that we'll be going ahead and understanding in through inspec. Finally, we will deploy the WAF, wherein we will see some examples of real-time attacks getting blocked against our sample application. And all these attacks can be viewed through a GUI-based dashboard, which is in Kibana. And as mentioned, the backbone of DevSecOps, which is vulnerability management, each and every tool will go ahead and send out or spool out the reports in archerysec, which will help us in creating the dashboards. Right. So that was a gist of our two-day course that each and every delegate will go ahead and have access to and will learn. Now let's discuss the different tools of trade. So we have threat modeling tools, which will be useful if you go ahead and want to go ahead and use like probably Microsoft threat modeling tool or threat spec. Next, we have in pre-commit hooks, we are using Talisman as a part of our lab. However, you can use Trufflehawk, JetHound, etc. You're free to use them. If you're looking at software composition analysis, you can use require.io or retire.js. We have dependency check that we have integrated in our pipeline. Similarly, we have SAST tools, IDE plugins, and secret management tools. And for vulnerability management, you can also have an alternative to archerysec, which is Jackhammer. For DAST, you can look at Arachne or Wapiti or W3AF. For security in infrastructure as code, you can look at Claire, you can look at Trivy, which will help you in performing scanning of your infrastructure. For compliance as code, we have inspec, which is integrated as a part of our lab. You can look at Kitchen CI or Docker Bench for security as an alternative. And as WAF, we have mod security WAF that we have already discussed today, which we have integrated. You can look at Naxi or INB, which can work as an alternative as well. Now, one of the important questions that I always get is, does programming language matter? So the answer to that is yes. Programming languages matter when it comes to DevSecOps, and they matter only in two stages, which is under static analysis and software composition analysis. Now, the reason for that is because depending on the language that you're using, you might have to go ahead and choose a tool. Right, so for example, we have a Java based lab, so we are using findcheck, bugs, and semgrep, etc. If you have a PHP or a Ruby based lab, the tool might differ. And similarly, for software composition analysis, we have dependency check. You might have to look at a different alternative if you're not using a Java based lab. And the second key aspect is, majority of the tools that are present, which are open source, they only support one or two languages at max. There's very few or probably only one such tool like sonarqube, which actually supports a lot of languages or majority of the languages. Apart from sonarqube, there are hardly any tools which support more than one language. and each and every tool will actually go ahead and focus on one single particular programming language, right? So this is the example wherein we have gone ahead and helped you to understand what are the different software composition analysis tools and static analysis tools that you can use depending on your own language that you have in your environment. So for example, as I already mentioned, for Java, we have dependency check and find seg bugs that we are using. If you have a Node.js based or a PHP based, you can use sonarqube, GR audit, you can use npm check, or you can use OSS review toolkit depending on your own environment. This is an example of a DevSecOps lab that you can actually go ahead and create in Ruby. And if you see, the only two stages that have got changed apart from everything else is the static analysis, security testing, and the software composition analysis stage. Similarly, in PHP, we have Sensio Labs Checker and PHP CS Security, which is the only two stage that gets modified if you want to go ahead and implement our lab in PHP. Similarly, for Python, we have Bandit and Safety as our SAST and SCA tools. And for Node.js, we have Node.js scanning and npm check. Now, one of the important things to understand about DevSecOps is just by going ahead and integrating a lot of tools, you'll not be able to go ahead and achieve DevSecOps. To achieve DevSecOps, you need to go ahead and have a change in the cultural mindset. You need to have people who embrace security. You need to create security champions within your organization. You need to have people who focus on collaboration, who want to learn security, who want to go ahead and identify and learn new aspects related to security as well. One of the key things to understand is the role of security team in DevSecOps is to try and eliminate the need of having a dedicated security team that acts as a gatekeeper. No, you need to have an automated system in place. These are some references related to DevSecOps that you can go ahead and read through if you're interested. So what are the key takeaways? So please understand that security is everyone's responsibility. This is one of the key terms when it comes to understanding DevSecOps. Please understand that feedback is one of the most important aspects of DevSecOps. The more feedback that you provide to stakeholders, the better your DevSecOps process will be. And as I said, DevSecOps is not a plug and play tool. There's no one size fit all. You might have to look at your environment, look at what is the reason of you moving to DevSecOps and how you might have to go ahead and implement it. So this is where I hand over now to Alan, wherein he will run us down through the further information related to the webinar.
Thank you, Abhijay. Yeah, I hope everyone found that of interest. Like we said, it is sampled from our training courses. Anybody that there's a lot of links there showed towards the end there. You won't be able to write down quickly. So if you want copies of the slides, we can produce those for you. Just let us know about that. So yeah, I hope everything was useful, really. We've got a whole load of courses coming up. There's a couple on the screen there which are for DevSecOps, which is relating to this, but there's also a lot of other subjects that we have webinars and training courses on. Probably best thing to do is check out our website if those are of interest. There will be a little questionnaire at the end if you complete that. One of the questions is are you interested in being contacted? I know it can be a pain to be, it won't be a sales pitch type thing. It just be fun to find out. But what it will do is give you entry into the prize draw. So you should be able to get, potentially get a free space. And if there are any courses you want to book yourself or your team or your colleagues on, just by attending this webinar, we'll be happily giving you a 20% discount on any courses you book. So yeah, just want to point out is historically all our training courses were run as a classroom thing or conferences. Obviously now we could do the whole thing due to the past year. Everything can be done remotely, so you can do them in your own time if you want to do a public course, or we can actually run tailored courses for your organisation. So it works either way, how you want to do it. What we're going to do now is we're going to hand over to a Q&A session because there's been some questions inputted during the training, and hand over to Lizzie. Lizzie, can you
Hi, thank you. Thank you, Alan, and thank you, Abhijay, as well. That was really informative and really interesting presentation there. So we have had a few questions in at the moment, Abhijay, so if I just let them, you know what they are. So someone has asked, when using Vault, if the developers don't have access to the token, how do they run tests locally or test the from end locally? Does that make sense, or would you like me to repeat the question? Sorry.
Okay, so normally what happens is using the vault, the developers will actually go ahead and gain access to a token. That token will be used to actually go ahead and fetch the credentials. The whole idea of using the token is to go ahead and have an access segregation in place, which means the developers no longer need to have access to the sensitive credentials. Now, the whole idea of having a vault is the lower number or the lesser number of people who have access to the sensitive information or to the credentials, the more likely you'll be able to have a safe and a secure environment.
Perfect, thank you for that. And then we do have one more question that has come in. What do you cover in terms of threat modeling?
So threat modeling,
yeah.
Yeah, so one of the key aspects that we have always looked at when it comes to DevSecOps is threat modeling. Now, the reason for that is because threat modeling is considered a backbone when it comes to security. Even before you go ahead and start implementing, whenever when you plan to go ahead and have DevSecOps within your environment, the very first thing that we recommend you to start with is to start with threat modeling. Threat modeling will actually go ahead and help you in identifying what are the actual applicable threats that you might have for your environment, and basis on those threats you can actually go ahead and then look at the different tools that might be the right for you. So for example, you go ahead and have a threat modeling done in your environment, and you'll understand that probably you only require software composition analysis or static security and just probably the continuous monitoring. You do not require vulnerability management or vulnerability assessment. So that is where threat modeling plays a very important role in DevSecOps.
Perfect, thank you, Abhijay. I do understand we have gone over the time, however, there are a few more questions, so if you want to stay on the webinar, then that's great, and if not, we will send a recording out to you tomorrow. So if that's okay, Abhijay, there's just a couple more questions here. So someone has said, does the training have a provision for cloud natives such as AWS or Azure DevOps?
Yes, so within our training, the very first thing that we go ahead and help delegates learn is more of an on-prem solution wherein they will have a hands-on exercise. However, once they are done with the course on the hands-on exercise, the final sections we move on to having that same on-prem setup, how they can go ahead and implement them in a native AWS type of environment. We will have a look at the different tools of trade. We will look at the different implementations. We'll look at the different threads that are applicable when it comes to having DevSecOps in an AWS type of an environment. So yes, we have a very good amount of sessions, very good amount of courses or content when it comes to having DevSecOps in AWS as a part of our training as well.
Perfect. Another question that's come in, someone has asked, are you able to elaborate from the training coverage perspective? Yeah, so that's all they've mentioned.
Okay.
Yeah.
So to elaborate, majority of the stages that we have shown today, right? So all the different 4 stages, which is the stage 1 wherein you go ahead and do the static analysis. We have stage 2 wherein you go ahead and do the dynamic analysis. We have stage 3 with infrastructure. We have stage 4 wherein we do continuous monitoring. Over the 2 days of the training, we will be going ahead and performing each and every stage. We'll be going ahead and first building our DevOps pipeline, wherein you will have a hands-on introduction of our personalized browser-based labs. Using those lab, you will actually go ahead and design or develop or implement a DevOps pipeline. Once you go ahead and get done with the DevOps pipeline, you'll start one by one integrating security tools. And over the course of 2 days, finally, you will be able to understand or achieve implementation of all the 4 stages of security and look at what exactly DevSecOps will, what exactly DevSecOps is.
Perfect. And then the last question that we've got in, Abhijay, that's all right with you.
Yeah.
So the last question is, most of the tools described are part of the Red Hat OpenShift. Do we need these tools in that case as well?
Right. So as I said, if you go ahead and look at the presentation, we have specifically mentioned that whatever tools that we have gone ahead and used as a part of our lab was specifically on how easy it was us to go ahead and play with them, or what features they provided which would go ahead and help us in our lab. We have provided alternatives during the course of the training as well. As I said in the disclaimer, we are not going ahead and endorsing any tool. Each and every tool that we are going ahead and discussing as a part of the training, we will have an alternative that we will show you that if this is not what you're looking for, these are the other alternative, both paid and open source tools that will work the same. And we have each and every tool listed down in that particular slide. So for every tool that we have mentioned in our training, for every tool that we go ahead and integrate as a part of DevSecOps pipeline, we will show you the other alternatives that might be applicable depending on your environment.
Great, thank you so much, Abhijay.
Most of the ones that subscribe to open source as well, aren't they?
Sorry,
that was Alan. Yeah, just Abhijay, am I right in saying most of the ones that we demonstrated there, they're mostly open source, which is accessible to anybody?
Yes. So majority of the tools that we have in our lab are open source, but as I said, depending on your environment, depending on the programming language that you have, you might have to look at a different alternative, and we will go ahead and provide those alternatives in our training as well. We'll have a look on those alternatives as well.
Perfect. So yeah, that is the end of the questions for today. Thank you so much to everyone who's asked a question there. I hope we've answered it for you. Just wanted to say thank you again for attending, everyone. We do have a survey once this webinar has ended. We would be really appreciative if you could just fill that out for us. It just gives us more of an indication of what we can improve on for future webinars, and also whether you want to be contacted about any of our services or trainings, etc. So yeah, thank you so much. Hope you have a lovely rest of the day wherever you are. So thank you again for coming to the webinar today. Goodbye, everyone.
Thanks, everyone. Cheers.
Bye. Thank you.